From the beautiful South Studios of Way Happy, this is Mr. Meyer in section 7.1, solving systems of two equations. Now, this is something you've been doing for some time, so we're probably going to go pretty quick, and you're probably going to like it, but let's make sure. So you can see here I have a system of two equations, and what that means is there's two equations, two unknowns. If you have two unknowns, you need two equations to solve it. If you have three unknowns, you need three equations to solve it. If you have five unknowns, you need five equations, oh my gosh, to solve it. But here you go. So all I'm going to do now is try to solve this. Now, one of the ways you learned early on is called substitution. Substitution is nice if you can make one of the equations, say either x equals or y equals. I can definitely make this first equation say x equals kind of easily. It'll equal that. So what does that mean? You substitute that into the second equation. That's substituting the first equation into the second. And so you'd have 2 times -7 minus 2y minus 3y equals 0. And you solve this because it has one unknown. You only need one equation, and therefore it should be solvable. So -14 minus 4y minus 3y equals 0. And some quick math would make this -7y equals 14. So y must be -2. Now you're not done because that's only y. You need to go back and tell me what x is. So -7 minus 2 times a -2, or -7 plus 4, which is -3, and there's the x. And now you got to give me both x and y. So usually the easiest way to do that, write it as a point. It is the point -3, -2. Everyone knows that's a point. That is your x value. That is your y value. Finito. You should be able to plug it in and have it work in both equations. You can check the first equation, it does work. You can check the second equation, -6 plus 6 is 0. It works beautifully. And that is your solution. Sometimes weird things can happen. Like look at this second one here to the right of it. It's already set up nicely for substitution. In fact, I will substitute this into that y. So what will I have? I will have 3x equals x cubed minus 6x. Now that was because somebody already solved for y for us. So that was kind of nice. Now I'll just, it's cubic. I'm going to get everybody on the same side. So 0 equals x cubed was at minus 9x. And looks like I could factor out an x. That would be really nice. I'd be left with x squared minus 9. And oh my gosh, that factors 2, difference of squares, x plus 3, x minus 3. And so I can already solve this pretty quickly. X is either 0, x is either -3, or x is 3. But do you realize what that means? Oh my, we have to go back and plug those 3 x's in to find out what the y values are. So when I plug in a 0, I'm going to plug it into this bottom one because that's easy. When I plug it in there, I get 0. When I plug -3 in, I get -9. And when I plug in +3, I get 9. And lo and behold, there would be my answers. One answer is 0, 0. One answer is -3, 9. And another answer is 3, 9. Beautificent. There are all three answers. Now, I'm kind of curious what the graph would look like. I would graph both of those and see where their intersections are, and I would expect to see them at those 3 points. So that is substitution. Let me ask you a question, and I'll be right back. Nice work. Now you're probably saying, wait, I remember another way. And that other way you remember is probably elimination. Now, what do you do with elimination? You just add those two equations together, but something better cancel. Either the x's better cancel or the y's, and if they don't, you make them cancel. And so if you see my example here, I think I'm gonna make the y's cancel because I'm crazy. And so I'm gonna multiply this one by -2, the first one. And so when I do that, I get -6x minus 14y equals -30. Make sure you get that right side. Most people will forget the right side if they make any mistakes on this. Now I made that a 14y, which means I'm going to multiply this by 7, and that will make it also a 14y. I'll actually make it the exact opposite. I'll make it a positive 14y. So what do we have? 7 times 5 is 35x's, and then I have plus 14y's equals, what is that, -28, right? And boom, there I go. That looks pretty good. So what happens? I am going to now be able to add because the y's will cancel, and again, giving us one equation with one unknown, which means it's solvable. So adding straight down, 29x, the y's cancel, equals negative 58. And that means x is negative 2. Now, that was way nicer and easier to solve, and I found x. Now, I could do the same thing, get the x's to cancel and find out y, or I could just plug this x back in. That's up to you. I'm just going to plug this x back in, though. Negative 2 going into the bottom one, there would be negative 10 plus 2y equals negative 4. I could have plugged it into any of the 4 equations, by the way. I will add that over now. I'll have 2y equals, it looks like 6 to me, and that means y is 3. And again, this is a point, so the point that they intersected at was negative 2 comma 3. That is beautiful. Again, I should be able to plug that in, and everyone would say, wow, nice work, right? And I should see it work in the top and bottom. That's what makes multiple choice system problems a little easier, because you could just plug them in instead of doing the math. But I like to do the math to make sure it's right. Also, graphing calculator, if I graph those two lines, I'm expecting them to intersect right there. All right, let's ask you another question and we'll be back. Beautiful work. All right, last but not least, let's talk about another way to solve, and probably what would be my favorite since Desmos is around. Again, graphing calculator, super idea. But what I could do is I could graph both of these and find out where they intersect, right? It's a great visual, and it just, gosh, it makes so much sense. Even looking at this problem right now, here's, kind of what I would be thinking. I have this graph and I look at the first one, which is natural logs. Now remember, natural logs go like this. They have the asymptote right here, and then they make this sweeping kind of graph like that. They get closer and closer to the asymptote, but then they pull away. Now this is stretched vertically by a factor of 2, so it's kind of hard to show, but that's the idea, right? And then I would graph this one. Well, that's a parabola that's down one, so it's like here, and then it's a parabola that goes like this. Now, the only thing I'm not sure is do they intersect at all? There's a total chance that they could miss. There's a chance they could intersect once. There's a chance they could intersect twice. So I'm thinking there's either, no answers, one answer, two answers, just from my crude drawing. Now, this is where I'd get a calculator and I'd type them in and I find the intersecting points. Or for those of us who love the people at Desmos, boom, you can see I typed in 2 natural log of x, got my red arc. I then typed in x squared minus 1, got my blue parabola, and it turns out that, yep, they only intersect that one time. I mean, I could zoom in here and see there's not any more intersections. So that's it. So I know the answer is 1-0. Again, Desmos saving the day and making us feel good. And it just made sense. I mean, even my drawing looked good. That's it. Have a great day. Stay happy, and I'll see you tomorrow.